Alright, in this video I'm going to factor this trinomial using the box method. And I do think I did this in another video, but here's another example. So to factor this trinomial using the box method, we're going to first start by drawing a box like such. Alright, there's a box. And the way this works is you're going to take the first term and you're going to write it in the upper left-hand corner. And then you take the last term and write it in the bottom right-hand corner. And then you take the coefficients, 10 times 3, 10 times negative 3, and we end up with negative 30. And then what you do is you now make a list of factors. 1, negative 30, negative 1, positive 30, 2, negative 15, negative 2, positive 15, and you just keep doing this, dot, 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 until you get, here I'll just do one more, 5, negative 6, until you get a set of factors that when you add them up, give you this coefficient right there. So let's add these up. 1 and negative 30 is negative 29, negative 1 positive 30 is positive 29, 2 plus negative 15 is negative 13. Oops, that's getting closer. Negative 2 plus positive 15 is positive 13. Oh, that's the one we want right there. So this is the one we want. You certainly don't have to write all these factors, but if it was hard coming up with this, then you would just continue to write all of the factors. Okay, so once I have the factors, I'm going to take one of them and put it here with an X, and I'll take the other one and put it here with an X, and no, it does not matter which order you put these in. And then I draw these little wings on my box like such, and now I'm going to look at the rows and the columns, and I'm going to factor out greatest common factors. Let's start with this bottom row. Negative 2x, negative 3, the only greatest common factor is negative 1. 10x squared, 15x, well, the greatest common factors of 5 and an x. Now I look at the rows. Let's look at this first row on the left. 10 and negative 2, greatest common factor is a 2. X squared and an x, so I can also have an x as a common factor. Now let's look at this last row. 15, negative 3. 3 is my greatest common factor, and I can't have an x as a greatest common factor because there's no x here. So now these things I have factored out on the side and the top, those are my factors. 5x minus 1 and 2x plus 3. And that's a technique for factoring a trinomial. Super handy here, especially if your leading coefficient is not 1. All right, let's do another example. This one is the difference of two cubes. So first of all, I have to recognize that I've got cubes here. Well, obviously I have a difference. I see a difference right there. So I can think of the 8 as a 2 cubed. Obviously the x is already cubed. The 125 is 5 cubed, and then obviously the y is already cubed. So I'll confess to you, I do not memorize these formulas because I use them so seldom. So here they are on page R27. That's the section in the back of your book. The formulas are right there, and just refer to them. So let me just go and demonstrate how this works. So when I factor this out based on the formula in the back of the book, I'm going to have a 2 and an x and a minus, a 5, and a y. That's my first factor. And then I'm going to be left with a 2 squared, an x squared, plus a 2 times a 5 times a y, plus a 5 squared and a y squared. And then of course I can clean this up a little bit. So I've got this 2x minus 5. And then let's just clean this up a little bit. 2 squared is 4. I still have the x squared. 2 times 5 is 10. And then 5 squared is 25. And in the back of the book, you'll notice that they use a and b, and all I did here is let my a represent 2x, and my b represents 5y. So see if you can follow the example in the back of the book to understand how the difference of two cubes works.